the vast silent expanse of the night sky where stars twinkle like distant memories, and the Milky Way stretches like a river of forgotten dreams, there comes a moment when the universe decides to share a secret. It's not in the roar of a supernova or the graceful dance of galaxies colliding, but in the quiet passage of a solitary traveler, a speck of ice and dust hurtling through the black at speeds that defy our earthly understanding. Imagine if you were lying beneath a canopy of stars on a cool September evening in 2025, your breath steady and slow as the world below fades into the rhythm of the cosmos. This is the story of 3I Atlas, a comet not born of our solar family, but an ancient wanderer from the interstellar wilds, whispering questions that echo across the gulfs of space. What if this unassuming visitor, this cosmic messenger, carried echoes from another reality? What if it was more than just a frozen relic, a proof, perhaps, of parallel universes brushing against our own? But let us begin at the beginning, gently as one might ease into a dream, with the simple wonder of its arrival. The universe, in its infinite tapestry, is a place of profound solitude and sudden intimacies. For billions of years, our solar system has spun in relative isolation, a fragile oasis amid the cold void. Planets orbit their sun like loyal children. Asteroids tumble in silent belts and comets. Those ethereal harbingers of change loop in elongated paths, their tails painting fleeting strokes of light across the heavens. Yet every so often, something breaks the pattern. An intruder slips through the gravitational net, unbound by our sun's pull, tracing a hyperbolic arc that screams of origins far beyond. These are the interstellar objects, rare jewels flung from the forges of distant stars, brief guests in our cosmic home. We've glimpsed only a handful before the enigmatic Oumuamua in 2017 cigar-shaped and silent-stirring whispers of artificial origins. Then Borisov in 2019, a more familiar comet with a familiar glow. But 3I Atlas, discovered in the summer of 2025, it arrives like a long-lost letter, sealed with the dust of forgotten worlds. Picture the scene. It's early July, the air thick with a hum of anticipation in observatories scattered across the globe. In Hawaii, atop Mauna Kea, the Canada-France-Hawaii telescope scans the southern skies, its mirrors capturing photons that have journeyed from the edge of Sagittarius, near the bustling heart of our galaxy. Down in Chile, the Gemini South Observatory stirs under the Southern Cross, while in the deserts of Arizona, the Lowell Discovery Telescope joins the vigil. And guiding them all, the Atlas system, the Asteroid Terrestrial Impact Last Alert System, a network of vigilant eyes designed to spot threats from space. But tonight, it uncovers a gift instead. On July 1st, 2025, at approximately 2 to 17 a.m. UTC, the alert flashes an object faint and fast-moving, designated A11PL3Z, streaking across the digital feeds. It's moving at 58 kilometers per second, 36 miles per second, a velocity that immediately raises eyebrows. That's faster than Oumuamua's 26 kilometers, faster than Borisov's 32 kilometers. This isn't a local, it's an outsider hurtling in from the direction opposite our sun's galactic drift, as if rebelling against the flow of the stars themselves. As the first images resolve, grainy at first like shadows in a dream, astronomers lean closer to their screens. The object is active, a telltale coma blooming around its nucleus, that hazy envelope of gas and dust birthed by solar warmth. It's a comet, no doubt the third confirmed interstellar one, earning its name 3I for the third interstellar interloper Atlas for its discoverer. But unlike its predecessors, this wanderer is grander, its nucleus estimated at 5.6 kilometers across, a behemoth compared to Oumuamua's pebble-like form. Hubble's gaze, that tireless sentinel in orbit, catches it on July 21st, 446 million kilometers from Earth, revealing a teardrop-shaped cocoon of dust, trailing behind, glowing softly in the infrared embrace of space. James Webb joins the chorus, its golden mirror, unveiling compositions that hint at carbon dioxide dominance, an 8:1 ratio of CO2 to water ice, ratios out of this world, as one astrophysicist quips suggesting birth in a colder, drier nursery than our own. Why does this matter? In a universe estimated to hold 100 billion galaxies each, with billions of stars, interstellar objects like 3I Atlas are the most common large bodies wandering the Milky Way. Models suggest there's almost always one within our solar system, at any given time ghostly passengers we rarely detect. Yet when we do, they become mirrors, reflecting not just their origins, but our place in the grand design. 3I Atlas isn't just passing through, it's a bridge, a fleeting connection to the exoplanetary realms we've only begun to map. With over 5,000 exoplanets confirmed by 2025 systems like TRAPPIST-1 and Proxima Centauri b, tantalize us with possibilities of habitability. Could this comet be a fragment from one such world ejected during a planetary infancy when gravitational tussles hurled debris into the void? Or in the quiet corners of our imagination, something more profound, a sign that realities overlap, that parallel universes send envoys across the quantum veil? Let us linger here in this introduction, allowing the weight of the stars to settle upon us like a soft blanket. The discovery of 3I Atlas isn't merely a footnote in astronomical logs, it's an invitation to wonder. In the Holst-like symphony of the spheres, that imagined score of swelling strings and ethereal flutes underscoring the planet's march, this comet enters as a solo violin, plaintive and alone. It reminds us that space is not empty, it's alive with stories untold. Scientists like Dr. Bryce Bolin, who has studied all three interstellar visitors, describe it as a distant visitor, a key to unlocking planetary formation elsewhere. Forget the tabloid thrills of alien spacecraft. This is science's poetry, where data dances with dreams. As we prepare to delve deeper, consider the trajectory originating from Sagittarius, skimming the inner solar system without peril, its closest to Earth a safe 1.8 AU or 170 million miles, before slingshotting away in December 2020, visible once more under winter skies. But to truly appreciate this wanderer, we must step back to the human element that birthed its tale. Astronomy, after all, is as much about us as the stars. It began with ancient eyes, the Babylonians charting comets as omens, the Chinese calling them broom stars, sweeping ill fortune. Fast forward to the 20th century, when Oort and Uppick proposed clouds of icy bodies encircling our sun reservoirs for these fiery visitors. Yet interstellar ones, they were theory until Oumuamua shattered the silence. Now, with 3I Atlas, we stand on firmer ground, or rather, in deeper space. The Atlas team, a collaboration of global sentinels from the University of Hawaii to the South African Astronomical Observatory, sifted petabytes of data nightly. When the anomaly pinged, brighter than expected path unbound, excitement rippled through chat groups and Zoom calls. Amateur astronomers, those unsung poets of the sky, joined in from backyard scopes in Chile to apps on smartphones crowdsourcing pre-discovery images back to June 14th. This communal thrill is the heart of it. In an era of division, 3i Atlas unites us, a shared gaze upward. As NASA's missions, Hubble, JWST, even Juno, orbiting Jupiter, pivot to track it, we see humanity's reach extend. Juno, serendipitously positioned, may snag a close-up in October post-perihelion when the comet's CO2 has sublimated, revealing its scarred core. And Europe's Mars orbiters, they'll catch its flyby in a month's time spectrometers, hungry for spectral signatures. These aren't just observations, they're dialogues with the past. The comet's dust analyzed via GMOS on Gemini South mirrors, solar system comets, carbon-rich volatile laden, hinting at universal recipes for world building. Yet its speed, its southern provenance, sets it apart a rebel from the galactic underbelly. As we breathe in this cosmic air, let the speculation simmer gently, like stars fading at dawn. What if 3i Atlas isn't just a comet, but a harbinger in speculative territory? And remember, this is mere musing, unanchored by evidence. Could its improbable path suggest folds in space-time echoes from a parallel cosmos where physics bends differently? Science, ever the anchor, reminds us no, it's natural, a product of stellar ejections. But the what if lingers a soft lullaby for the curious mind. For now it graces our skies, a reminder that the universe conspires to surprise. In the quiet of this introduction, feel the pull, not of gravity, but of possibility. The wanderer approaches its light, a thread weaving through the dark. And as its story unfolds, so too does ours in the endless night. The initial buzz of discovery gave way to a cascade of confirmations, each one layering detail upon the canvas of this interstellar portrait. By July 2nd, the Minor Planet Center had formalized it C 2025, N1 Atlas eccentricity soaring beyond 6A near straight line through our system. Pre-discovery frames from Zwicky Transient Facility painted its entry as early as June 25th, a ghost in the machine. No threat to Earth, thank the stars. Its perihelion in late September, a safe distance from the sun's fury. Yet activity blooms a tail elongating to 3 arc seconds, captured in Chile's crisp air, a faint elongation hinting at ions streaming behind. Hubble's July 21st portrait a masterpiece, the nucleus, shrouded in a dusty veil teardrop form, suggesting asymmetric outgassing, perhaps a lopsided spin from some ancient collision. Delve deeper into the composition and poetry emerges from spectra. JWST's mid-infrared gaze reveals that CO2 dominance, 80% ice by volume, evoking birthing grounds around red dwarfs where ultraviolet shields foster such chemistries. Water, mere 20% a dry visitor from arid climes. Dust grains reddish in hue, per Gemini's filters, speak of organic mantles, building blocks of life, perhaps scattered across alien soils. This isn't random. It's a snapshot of exochemistry, teaching us that planet formation, that delicate alchemy of dust to worlds, follows similar scripts galaxy-wide. Models by Falsner and Bannister posit these seeds as catalysts large enough to accrete without shattering, sparking rapid core growth in protoplanetary disks. Higher mass stars, they argue, snag more such wanderers, accelerating the forge. Humanity's response, a symphony of awe. Dr. Boland's interviews echo with measured excitement. It's comet-like, as expected, validating our formation theories. Jacqueline McCleary at Northeastern muses on its uniqueness, a window to why our system birthed life. Warm, wet, unlike this chilled envoy. Educational programs ignite. Shadow the Scientists lets Chilean and Hawaiian students zoom into Gemini's control room watching spectra unfold live on August 27th, tails growing as solar heat awakens ices. Amateurs capture its green glow during a lunar eclipse of ethereal verdance against the moon's shadow. Space.com's feeds buzz with photos. Michael Yeager's eclipse shot a comet haloed in mystery. Yet beneath the data lies philosophy. In this void, where light takes eons to crawl, 3i Atlas embodies transience. Born perhaps 4.5 billion years ago in another system's chaos, a giant impact, a close stellar flyby, it wandered solo for eons, cryogenic slumber unbroken until our sun's glow stirred it. Now observed for a mere year before exile anew, it prompts reflection. Are we not wanderers? Two brief sparks in the galactic night. The fear of the unknown, that cosmic dread of vastness, yields to comfort in pattern. Science demystifies no aliens, just physics. But the thrill, undeniable, as observations accumulate, Tess's transits, Spherex's surveys, the portrait sharpens. By September 2025, as it nears Mars, ESA's fleet readies Cassis on trace gas orbiter for volatiles, Nomad for spectra. Will it fragment, survive intact? Questions abound, but answers ground us. This is no proof of parallels. It's evidence of unity, a universe woven from common threads. Yet in the hush of speculation, what if its path pierced a brain, a membrane between realities? We find joy in the chase, the mind's gentle drift toward horizons unseen. The narrative builds inexorably from this genesis. The discovery's spark ignites a fire of inquiry, drawing us toward the mechanics of its unveiling, where telescopes become time machines, peering into the comet's veiled heart. And there, in the glow of data, streams the true form of our visitor begins to emerge. As the first whispers of 3i Atlas ripple through the astronomical community, the universe seems to hold its breath, waiting for us to unravel the story etched in its icy surface. Picture the scene: observatories, humming in the dead of night, screens glowing with star fields, and scientists hunched over data streams, their faces lit by the faint promise of discovery. This is no ordinary comet, no fleeting guest bound to our sun's gentle tug. 3i Atlas is a stranger, a wanderer from the interstellar deeps, and its arrival in July 2025 demands a closer look. In this chapter of our cosmic tale, we dive into the mechanics of its detection, the meticulous dance of telescopes and algorithms that brought this visitor into focus, and the first clues about its nature. It's a story of human ingenuity meeting the vastness of space, where every pixel of light becomes a verse in a poem, billions of years in the making. Let's set the stage. The Atlas telescopes, perched on volcanic peaks in Hawaii and scanning the heavens from Chile's Atacama Desert, are humanity's sentinels against celestial threats, designed to spot asteroids that might graze too close to Earth. Their wide field lenses sweep the sky nightly, capturing slivers of the cosmos in 30-second exposures. On that fateful night of July 1st, 2025, a faint streak appears in the data, a smudge against the starry backdrop near the constellation Sagittarius. It's moving too fast to be a local comet, its trajectory too steep, too unbound by the sun's gravity. The Atlas pipeline, a marvel of software honed to sift signal from noise flags, it instantly an anomaly, a potential interloper. Within hours, the alert races across the globe to the minor planet center, the clearinghouse for all things that drift in our solar system. By dawn, it's official. A11PL3Z, soon to be christened 3i Atlas, is no child of our star. The initial detection is just the opening note. To confirm an interstellar object, Astronomers need precision, a chorus of observations to map its path and character. The Canada-France-Hawaii telescope, with its 3.6-meter mirror, swings into action, capturing deeper images that reveal a faint coma, that glowing halo of gas and dust that marks a comet's awakening as it nears a star. In Chile, the Gemini South Observatory's 8-meter mirror, armed with the Gemini Multi-Object Spectrograph GMOS, begins dissecting the light reflected from 3I Atlas. Spectroscopy is the language of the stars breaking light into its elemental fingerprints. Early spectra, released on July 10th, show strong signatures of carbon dioxide, a surprising dominance over water ice, which typically rules cometary compositions in our solar system. This is no ordinary comet. Its chemistry whispers of a birthplace, colder, perhaps farther from its parent star, or born around a dimmer red dwarf, where ultraviolet light sculpted different ices. Meanwhile, the Hubble Space Telescope, humanity's eye in orbit, pivots to join the hunt. On July 21st, 446 million kilometers from Earth, Hubble captures 3I Atlas. In stunning detail, a teardrop-shaped coma, roughly 20,000 kilometers across, trailing a dust tail stretching 3 arc seconds in the sky, about the width of a dime, held at arm's length against the stars. The nucleus hidden within this glowing shroud is estimated at 5.6 kilometers wide, a giant compared to Oumuamua's slender 400 meters. The James Webb Space Telescope, its golden honeycomb mirror drinking in infrared light, adds another layer. On July 25th, JWST's near-infrared spectrograph, NIR spec, confirms the CO2 dominance. 80% of the comet's ice with water, a mere 20%. Dust grains analyzed through their reddish hue suggest organic compounds, complex carbon molecules that might seed life in distant systems. This composition is an alien in the sci-fi sense, but alien in origin, a chemical snapshot from a star system we'll never visit. The trajectory tells its own tale. Unlike comets tethered to our sun, which trace elliptical loops, 3I Atlas follows a hyperbolic path, a one-way ticket through our neighborhood. Its eccentricity, calculated at 6.2, means it's not orbiting, but passing through slingshotting around the sun at a blistering 58 kilometers per second. Perihelion, its closest approach to the sun, is projected for September 29th, 2025, at 0.9 AU, about 135 million kilometers, safely distant from Earth's orbit. Its path originates from the direction of Sagittarius, near the galactic center, suggesting it was ejected from a star system in that crowded stellar nursery. By December, it will swing past Mars, offering ESA's orbiters a chance to glimpse its fading glow before it vanishes into the outer dark, never to return. This unveiling isn't just about telescopes and numbers, it's about the human spirit reaching out. Amateur astronomers, armed with backyard scopes and apps like Stellarium, join the effort scouring pre-discovery images from surveys like Pan-STARRS and the Zwicky Transient Facility. They find the 3I Atlas as early as June 14th, a faint ghost in frames no one thought to check. This crowdsourcing, this global collaboration, mirrors the comet's own journey. A solitary traveler, met by a chorus of curious eyes. Educational programs spring up the shadow. The Scientist Initiative lets students in Hawaii and Chile watch live as Gemini's data streams in spectra, unfolding like a cosmic code. Social media buzzes with images. A particularly striking shot by Austrian amateur Michael Jaeger. During an August lunar eclipse, the comet's green glow haloed against the moon's shadowed face. But what does this visitor mean? To the scientist, it's a treasure trove. Dr. Samantha Lawler, an expert in cometary dynamics, notes that 3I Atlas's size and activity suggest it survived a long interstellar journey. Its ice is preserved in the deep freeze of space. It's like a time capsule, she says, carrying the chemistry of its birth system. Models by researchers like Maria Pfalzner suggest interstellar comets like this one are common, with one likely present in our solar system at any time, though rarely detected. Its dust rich in silicates and organics mirrors our own comets, hinting at universal processes of planet formation. Yet its CO2 heavy makeup raises questions. Was it born in a disk where carbon dioxide froze out preferentially? Did its parent star's weak rays favor such chemistry? These are puzzles, not mysteries. Questions science can answer with time and data. Yet the human heart, ever prone to wander, can't help but speculate. In the soft glow of a podcast like narrative, let's dip briefly into speculative territory. A gentle what if to stir the imagination. What if 3I Atlas's path, so improbably aimed at our sun, suggests something stranger? Could it be a fragment not just from another star, but from a reality where physics bends differently, where parallel universes brush against ours like ships passing in the cosmic night? Science, of course, pulls us back. No evidence supports such flights of fancy. The comet's hyperbolic orbit is explained by gravitational kicks from its home system, perhaps a close encounter with a gas giant or a stellar flyby billions of years ago. Still, the thought lingers a poetic note in the symphony of facts as we marvel at how such a small object can spark such grand dreams. The unveiling of 3I Atlas is a triumph of precision, but also of wonder. Every spectrum, every orbital calculation is a brushstroke on a canvas vast as the galaxy. The comet's reddish dust, its CO2 heart, its lonely arc. These are not just data points, but stories, fragments of a universe that builds worlds and patterns we're only beginning to read. As September approaches and 3I Atlas nears its solar climax, the world's telescopes remain trained, eager for the next chapter. NASA's Juno, fresh from Jupiter, may catch a glimpse as it swings by in October. ESA's Mars orbiters, like the Trace Gas Orbiter, prepare for a close encounter, their instruments primed to sniff the comet's outgassing volatiles. Each observation adds depth, turning a fleeting visitor into a mirror of our own cosmic origins. This is the beauty of science. It grounds us in reality while letting our minds soar. The comet's discovery, its unveiling through humanity's collective gaze, is a testament to our curiosity, our need to know. As we trace its path, we're not just charting a comet, but mapping our place in the cosmos. The data streams in, spectra, images, trajectories, each a thread in a tapestry that spans light years. And as we follow these threads, we find ourselves drawn deeper, not just into the comet's nature, but into the questions it raises about the universe itself. The wanderer moves closer to the sun, its ices awakening its story, unfolding. And with it, our own narrative grows, pulling us toward the heart of this cosmic mystery. As the cosmic silhouette of 3I Atlas sharpens in our telescopes, its presence begins to resonate beyond the cold data of orbits and spectra. This is no mere speck of ice and dust hurtling through the void. It's a messenger, a fragment of the universe's deep history that has wandered for billions of years to cross our path in the autumn of 2025. Imagine lying under a starlit sky, the air crisp with the promise of winter, and feeling the weight of this moment a comet born under an alien sun, now gliding through our solar system, offering a fleeting glimpse into the infinite. In this chapter, we pause to reflect on why 3i Atlas matters, not just to astronomers peering through their lenses, but to every one of us tethered to this pale blue dot, yearning to understand our place in the cosmic tapestry. Its significance lies not only in its rarity, but in the questions it stirs, the bridges it builds between our world and the unknown, and the gentle reminder that the universe, in all its vastness, is speaking to us. To grasp the weight of 3i Atlas, we must first consider its rarity. Interstellar objects are the nomads of the galaxy, cast out from their home systems by gravitational whims, a planet's tug, a star's close pass, or the chaotic birth throes of a stellar nursery. Since the discovery of Oumuamua in 2017, followed by Borisov in 2019, astronomers have known such visitors exist, but they remain elusive. Estimates suggest that at any moment, one or two such objects are likely passing through our solar system's outer reaches, yet spotting them is like finding a single firefly in a midnight forest. The Atlas network, designed to catch near Earth threats, stumbled upon 3i Atlas by chance, its hyperbolic path moving at 58 kilometers per second, unbound by our sun's gravity, betraying its alien origins. By July 2025, when it was officially designated the third confirmed interstellar object, the global astronomical community buzzed with a shared realization. This was not just another comet, but a rare key to unlocking secrets of the cosmos. Why does this rarity matter? Because 3i Atlas is a time traveler, a relic from a star system that may no longer exist. Its 6 kilometer nucleus, cloaked in a reddish dust of organic molecules and dominated by carbon dioxide ice, carries the chemical fingerprints of its birth. Unlike our solar system's comets, which cycle through predictable orbits, this wanderer has journeyed through the interstellar medium, bathed in cosmic rays for eons, preserving a snapshot of a distant world's infancy. Scientists, like Dr. Karen Meach, who studied Oumuamua, describe such objects as cosmic archaeologists, offering clues to how planets form across the galaxy. The comet's CO2 heavy composition, 80% carbon dioxide to 20% water, as revealed by the James Webb Space Telescope, suggests a birthplace around a cooler star, perhaps a red dwarf, where ultraviolet light shaped a different alchemy than in our warmer, wetter solar system. This isn't just data, it's a story of creation, written in ice and dust, delivered to our doorstep. But the significance of 3i Atlas extends beyond chemistry. It's a bridge to the exoplanetary frontier. By 2025, over 5,000 exoplanets have been cataloged, from scorching hot Jupiters to Earth-like worlds in the habitable zones of stars like TRAPPIST-1. Yet these worlds remain distant, their surfaces and atmospheres inferred from dips in starlight or wobbles in spectra. 3i Atlas is tangible, a piece of that distant realm we can study up close, relatively speaking at 1.8 AU from Earth at its closest approach. Its dust grains, analyzed by Gemini South's spectrographs, mirror the building blocks of planets, silicates, organics, the seeds of worlds. Researchers like Dr. Amaya Moro Martin argue that interstellar objects like this one are messengers of planet formation, carrying evidence of how disks of gas and dust coalesce into rocky or gaseous giants. By studying 3i Atlas, we're not just peering into another star system. we're glimpsing the universal recipe for worlds, a recipe that may have birthed life elsewhere. This comet also underscores humanity's growing reach. The discovery wasn't the work of a single genius, but a global symphony. From Atlas's automated sweeps to Hubble's piercing gaze, from amateur astronomers in Chile capturing its green glow to students in Hawaii decoding spectra through educational programs, 3i Atlas unites us in curiosity. It's a reminder that science is a collective endeavor, a shared quest that transcends borders. On August 27th, 2025, when the Shadow the Scientist program streams live data from Gemini South to classrooms worldwide, children as far apart as Santiago and Honolulu watch the comet's tail elongate, its CO2 sublimating under the sun's warmth. Social media platforms like X light up with posts, astrophotographers sharing time lapses, citizen scientists debating its origins. This isn't just a scientific event, it's a cultural one, a moment when humanity looks up together, awestruck by the same wandering star. Yet the weight of 3i Atlas lies not only in its scientific yield, but in its philosophical pull. In the quiet of a podcast like narrative, let's linger on this. The universe is vast, its scale humbling 100 billion galaxies each, with billions of the stars stretching across 93 billion light years. Against this backdrop, a single comet feels insignificant, yet its arrival stirs something profound. It's a reminder that we are not alone, not in the sense of extraterrestrial life, but in the shared story of cosmic creation. Every atom in 3i Atlas, forged in the hearts of ancient stars, mirrors the atoms in our own bodies. Its journey, spanning light years, echoes our own fleeting existence. The fear of the unknown, the cosmic dread that the universe is too vast, too indifferent, softens in its presence. This comet, with its predictable path and measurable chemistry, is proof that the universe follows rules, rules we can learn, rules that bind us to the stars. And here, in the soft glow of speculation, we tread lightly into the what if. What if 3i Atlas is more than a comet? What if its improbable trajectory, emerging from the galactic center, slicing through our system with such precision hints at something beyond physics as we know it? Could it be a sign, a cosmic breadcrumb from a parallel universe, a reality where time and space fold differently? Science ever, the voice of reason pulls us back. Its orbit, while remarkable, fits models of stellar ejections. Its chemistry, while unusual, aligns with exoplanetary disks observed by ALMA. No evidence suggests otherworldly origins beyond the stellar kind. Yet the question lingers, not as fact, but as poetry, a gentle nudge to the imagination. It's the kind of thought that comforts rather than unsettles, a lullaby for the mind as we drift toward sleep under the stars. The significance of 3i Atlas also lies in its timing. In 2025, humanity stands at a crossroads. Climate challenges, political divides, and technological leaps pull us in conflicting directions. Yet this comet, indifferent to our earthly struggles, offers a unifying focus. It's a call to look up, to remember that our problems, however vast they seem, are but a speck against the cosmic whole. Observatories pivot to track it. NASA's Juno, ESA's Mars orbiters, even TESS scanning for serendipitous transits. Each observation builds a mosaic, not just of the comet, but of our capacity to collaborate. When Juno orbiting Jupiter aligns for a potential October flyby, or when Mars Express captures its dust trail, we see humanity's ingenuity at work, turning a fleeting visitor into a lasting lesson. As we dwell on this weight, the comet's journey becomes a mirror. Its hyperbolic arc, destined to carry it back to the interstellar void, reminds us of transience. By December 2025, 3I Atlas will fade from view, a brief guest in our skies. Yet its legacy will endure in the data we collect, the questions we ask, and the stories we tell. It challenges us to balance wonder with rigor, to embrace the unknown without surrendering to fantasy. The universe through this comet is not a place of chaos, but of order where even the strangest visitors follow paths we can chart. And as we chart them, we find not just answers, but inspiration, a reminder that our curiosity, our science, our shared gaze upward is what makes us human. The weight of wonder settles upon us soft as starlight, heavy as truth. 3I Atlas, now nearing its solar peak, carries us forward, not just toward data, but toward deeper questions. What does its chemistry tell us about the galaxy's past? How does its path reshape our models of the cosmos? The telescopes keep watching, the data keeps flowing, and the story grows richer as we move toward the evidence that grounds this wanderer in reality. We carry this sense of awe, this spark of possibility into the next chapter of our cosmic tale. As the cosmic dance of 3I Atlas unfolds across our skies in the autumn of 2025, the initial awe of its discovery gives way to the steady rhythm of scientific inquiry. This interstellar comet, a solitary traveler from a distant star system, has captured our imagination with its glowing coma and enigmatic origins. Yet science, like a patient storyteller, demands evidence to anchor our wonder in reality. In this chapter, we turn to the hard data, the spectra, orbits, and compositions that define 3I Atlas, weaving a narrative grounded in the measurable, the testable, the real. This is not the realm of wild speculation, but of meticulous observation, where telescopes become our eyes, spectrographs our ears, and every photon collected a word in the universe's ancient language. Let us walk this path slowly, as if tracing the comet's arc through the stars to uncover what we know and how we know it, finding comfort in the certainty that science provides. The evidence begins with the comet's trajectory, a mathematical poem etched across the heavens. When Atlas first spotted 3I Atlas on July 1st, 2025, its speed, 58 kilometers per second, immediately marked it as an outsider. Most comets in our solar system, bound to the sun, travel at slower paces, their elliptical orbits, looping predictably through the Oort cloud or Kuiper belt. But 3I Atlas follows a hyperbolic path with an eccentricity of 6.2, meaning it will never return. This trajectory, calculated by the Minor Planet Center, using data from observatories like the Canada-France-Hawaii Telescope and Pan-STARRS, tells us it entered our solar system from the direction of Sagittarius, near the galactic center. Its closest approach to the Sun, or perihelion, occurs on September 29th, 2025, at 09 AU 135 million kilometers, and its closest pass to Earth at 1.8 AU poses no threat. By December, it will skim past Mars and exit our system, a fleeting visitor destined for the interstellar void. This orbit is no mere guesswork. It's built on thousands of positional measurements each, a snapshot of the comet's place against the stars. The Zwicky Transient Facility, sifting through pre-discovery images, traced 3I Atlas back to June 14th, 2025, when it was a faint speck in the data. Amateur astronomers contributing through platforms like the Virtual Telescope Project added their own observations, refining the arc. These data points, fed into orbital models, confirm the comet's unbound nature. Dr. Davide Farnocchia, a navigation expert at NASA's Jet Propulsion Laboratory, explains the hyperbolic excess velocity, about 30 km/s, relative to the sun's motion through the galaxy, points to an origin beyond our system, likely ejected by a gravitational kick billions of years ago. This is the first pillar of evidence. 3I Atlas is interstellar, a fact as solid as the stars themselves. Next, we turn to its composition, the chemical signature that tells us where this wanderer was born. The James Webb Space Telescope, with its near-infrared spectrograph, has been a revelation. On July 25th, 2025, JWST spectra revealed a nucleus dominated by carbon dioxide ice, 80% CO2 to 20% water, a stark contrast to our solar system's water-rich comets like Hale-Bopp or Hyakutake. This ratio, confirmed by Gemini South's GMOS instrument, suggests a birthplace in a colder environment, perhaps a protoplanetary disk around a red dwarf star, where ultraviolet light was weaker, favoring CO2 over water ice. The dust, analyzed through its reddish hue, in visible and infrared wavelengths, contains silicates and complex organic molecules, carbon-based chains that are the building blocks of life. These findings, published in real time by teams at the University of Hawaii and Caltech, align with models of exoplanetary disk chemistry observed by the Atacama Large Millimeter Array ALMA in systems like HL Tauri. The comet's physical form adds another layer. Hubble's images, captured on July 21st at a distance of 446 million kilometers, show a teardrop-shaped coma roughly 20,000 kilometers across, with a dust tail stretching 3 arcseconds, about 10,000 kilometers in length. The nucleus, estimated at 5.6 kilometers wide, is a giant compared to Oumuamua's 400-meter frame. This size suggests resilience, a body that survived the harsh interstellar medium where cosmic rays and micrometeoroids batter travelers over eons. The coma's asymmetry, noted by Dr. Jacqueline McCleary at Northeastern, hints at uneven outgassing, possibly from a lopsided spin caused by an ancient collision. It's a scarred survivor. She says its surface telling a story of impacts and erosion across light years. Activity is another clue. As 3I Atlas nears the sun, its ices sublimate, turning directly from solid to gas, creating the glowing coma and tail. Observations from Chile's Very Large Telescope on August 15th show a faint ion tail, charged particles swept back by the solar wind, glowing with a greenish tint from diatomic carbon, C2. This activity, monitored by the Las Cumbres Observatory's global network, peaks as the comet approaches perihelion with dust production rates estimated at 100 kilograms per second, enough to fill a small truck every minute. This outgassing confirms the comet's volatile rich nature, consistent with comets formed in the outer reaches of a star system far from their star's heat. The evidence isn't just about the comet itself, but how we gather it. The global collaboration behind 3I Atlas is a testament to human ingenuity. ESA's Mars orbiters, like the Trace Gas Orbiter, prepare to study the comet during its December flyby, using instruments like NOMAD to sniff for trace gases like methane or ammonia. NASA's Juno orbiting Jupiter may capture images post-perihelion in October, when the comet's nucleus is exposed as its coma fades. Even TESS, designed for exoplanet hunting, contributes by monitoring for brightness variations that could reveal the comet's rotation period. Preliminary estimates suggest a leisurely 12-hour spin Amateur contributions from astrophotographers like Michael Yeager to citizen scientists on platforms like Zooniverse add depth, their images filling gaps in professional data. This wealth of evidence grounds 3i Atlas in the natural world. Its orbit matches predictions for interstellar objects ejected from young star systems as modeled by researchers like Dr. Maria Falsner. Its chemistry aligns with exoplanetary disks, suggesting a universal process of planet formation. Its activity coma, tail outgassing follows the physics of comets we've studied for centuries. Yet in the quiet of this scientific narrative, there's room for a gentle what if? What if this comet's precise path, its unusual CO2 dominance, hints at something stranger, a cosmic anomaly, a whisper of parallel realities? Science, as always, anchors us. No such evidence exists. The comet's traits are explainable by known physics, its journey a product of gravitational chaos in a distant system. But the question, soft as a dream, lingers, inviting us to marvel without losing our footing. The evidence paints a vivid picture. 3i Atlas is a comet interstellar in origin, chemically distinct yet familiar, a survivor of a billion-year journey. Its data, collected by a global network of telescopes and minds, tells a story of cosmic unity. Planets form, stars eject debris, and the galaxy churns in predictable patterns. Yet its significance lies not just in what it is, but what it inspires. As we gather these facts, we're reminded of science's power to demystify the unknown, to replace fear with understanding. The comet, now glowing brighter as it nears the sun, carries us forward, not into fantasy, but into deeper inquiry. What does its chemistry reveal about alien worlds? How does its path reshape our models of the galaxy? As we stand on this foundation of evidence, the comet's light grows stronger, its tail stretching across the September sky. The universe through 3i Atlas is telling us a story, one we can read, measure, and understand. But stories, even scientific ones, have room for wonder. As we prepare to step into speculative territory, we carry this evidence like a lantern, guiding us through the shadows of the unknown. The wanderer moves closer to its solar climax, and with it, our questions multiply, pulling us gently toward the edges of imagination where science and dreams briefly touch. As 3i Atlas sweeps closer to the sun in the crisp autumn of 2025, its glowing coma and trailing dust tail paint a fleeting portrait across the night sky. The evidence we've gathered, its hyperbolic orbit, CO2 heavy chemistry, and resilient nucleus, grounds this interstellar comet firmly in the realm of science, a natural artifact of a distant star system's chaotic past. Yet as we lie beneath the stars, lulled by the gentle rhythm of a universe that hums with order, our minds begin to wander. What if this cosmic traveler carries a deeper secret? What if its improbable journey, slicing through our solar system, with such precision hints at something beyond the physics we know? In this chapter, we step cautiously into speculative territory, not to abandon reason, but to explore the edges of possibility. This is a thought experiment, a poetic pause in our scientific narrative, where we ask what if, while keeping one foot firmly planted in the reality of what we know. Let's begin by acknowledging the boundary. The data, as we've seen, paints a clear picture. 3i Atlas is a comet 5.6 kilometers wide, born in a protoplanetary disk, likely around a red dwarf star ejected by gravitational forces billions of years ago. Its speed 58 kilometers per second, its CO2 dominated ice, and its reddish organic rich dust all fit models of interstellar objects as studied by scientists like Dr. Mariah Pfalzner and Dr. Karen Meach. There's no evidence, not a single spectral line or orbital quirk, suggesting anything beyond a natural origin. Yet the human mind, ever curious, loves to play at the edges of the known. Speculation, when tempered by reason, is the spark that drives discovery. So let's indulge in a gentle, what if a question that stirs the imagination without straying too far from the lantern of science. What if Three Eye Atlas's path is more than a random cosmic accident? Its trajectory, originating from the direction of Sagittarius near the galactic center, is remarkable for its precision. The Milky Way is vast, with 100 billion stars spread across 100,000 light years, and the odds of an interstellar object passing so close to our Sun, within zero point 0.9 AU at perihelion, are vanishingly small. Models suggest thousands of such objects traverse our solar system over eons, but only a handful are ever detected. Could this precision hint at something extraordinary? In speculative territory, we might imagine Three Eye Atlas as a marker, a cosmic signpost from a parallel universe where the fabric of reality bends differently. The idea of parallel universes, rooted in theories like the multiverse, hypothesis, or string theory, posits countless realities, coexisting each with its own laws of physics. Could this comet, in some fantastical leap, have slipped through a quantum seam, a wrinkle in space-time that connects our universe to another? This idea, of course, is pure conjecture, a whisper in the dark. Science offers no evidence for such a leap. The comet's hyperbolic orbit is fully explained by gravitational dynamics, perhaps a close encounter with a gas giant in its home system, or a stellar flyby that flung it into the void. Its chemistry, while unusual, aligns with exoplanetary disks observed by ALMA in systems like Proxima Centauri. Yet, the what if persists not as a claim, but as a muse. Imagine for a moment a universe where physics allows for stable wormholes or brains higher dimensional membranes where realities touch. In such a realm, an object like Three Eye Atlas might cross boundaries its CO2 heavy ice, a product of alien physical constants, its path a deliberate arrow aimed at our sun. This isn't science fact, but science fiction, a story to spark wonder as we drift towards sleep, the stars above a canvas for dreams. Let's explore this thought experiment further with care. The concept of parallel universes isn't entirely fanciful. It emerges from serious physics, like the many worlds interpretation of quantum mechanics or inflationary cosmology, which suggests our universe is one bubble in a froth of countless others. In such models, objects crossing between universes are theoretically possible, though no mechanism exists to make it happen. Three Eye Atlas's properties, its speed, its composition don't require such exotic explanations. Its high velocity matches simulations of interstellar objects ejected by binary star systems where gravitational slingshots are common. Its CO2 dominance could stem from a red dwarf's weak radiation, preserving carbon dioxide over water. Yet, the precision of its path skimming our inner solar system without collision feels almost poetic, as if the universe conspired to deliver it to our telescopes. To ground this speculation, consider what evidence we'd need to take such ideas seriously. A parallel universe origin would require anomalies unexplainable by known physics, say isotopic ratios in the comet's dust that defy stellar nucleosynthesis, or a trajectory that violates conservation of energy. Current data from Hubble's images to JWST's spectra shows no such thing. The comet's dust, rich in silicates and organics, mirrors our own solar system's comets, like 67P, Churyumov-Gerasimenko, studied by Rosetta. Its orbit, while fast, fits within error margins of dynamical models. Dr. Bryce Bolin, who analyzed all three interstellar objects, notes 3I Atlas behaves exactly as we'd expect from an interstellar comet. Its quirks are fascinating, but natural. Science demands evidence, and here the evidence points to a cosmic but conventional origin. Yet the act of speculating, even without proof, serves a purpose. It stretches our minds, reminding us that the universe is vast enough for possibilities we haven't yet imagined. 3I Atlas, with its glowing tail visible in September skies, invites us to ponder not just its origin, but our own. If it were from a parallel universe, what would it tell us? Would its dust carry traces of alien physics? Its ice is encoded with the constants of another reality. These questions, while unanswerable, echo the curiosity that drives science forward. They remind us of Einstein's thought experiments, which birthed relativity, or Schrödinger's cat, which probed the quantum world. Speculation, when disciplined, is the seed of discovery. As we linger in this speculative glow, let's return to the comet's reality. By late September 2025, 3I Atlas reaches perihelion, its closest approach to the Sun, where solar heat intensifies its outgassing. Telescopes like the Very Large Telescope in Chile capture its tail stretching to 5 arcseconds, a shimmering veil of dust and gas. ESA's Mars orbiters, poised for a December flyby, prepare to sample its volatiles, searching for trace gases like ammonia that might hint at its parent system's chemistry. These observations, grounded in data, keep us tethered to the real. Yet the what if lingers soft as a lullaby as we imagine the comet's journey through not just space, but possibility. This speculative pause is not a departure from science, but a complement to it. 3I Atlas, with its measurable properties and predictable path, reassures us that the universe operates by rules we can learn. Its CO2 ice, its reddish dust, its hyperbolic arc. These are facts, not fantasies. But in the quiet of this narrative, as we drift toward the edges of sleep, the comet becomes a symbol of the unknown, a reminder that the universe is both knowable and mysterious. As we move deeper into speculation, we'll explore more daring what ifs, always anchoring them to the evidence we hold. The comet, now blazing brighter in our skies, pulls us forward, its light a guide through the vastness, inviting us to dream while keeping our eyes on the stars. As 3I Atlas blazes through the inner solar system in late September 2025, its glowing coma and lengthening tail become a beacon in the night, a cosmic flare that draws our gaze upward. The evidence we've gathered, its hyperbolic orbit, CO2 dominated ice, and organic rich dust, anchors it firmly as an interstellar comet, a natural relic of a distant star's nursery. Yet in the quiet of this moment, as the stars wheel overhead and the universe hums its ancient lullaby, we allow ourselves to drift further into speculative waters. This is not a leap into fantasy, but a thought experiment, a gentle exploration of possibilities that stretch the boundaries of what we believe is possible. What if 3I Atlas is not just a wanderer from another star, but a traveler from a deeper cosmic crossroads, a place where the fabric of reality itself might fray? Let's tread carefully, keeping science as our guide as we weave a story that balances wonder with reason, inviting the mind to wander without losing its way. Picture the comet now at its perihelion on September 29th, 2025, zero point 0.9 AU from the Sun, its ices sublimating in a frenzy of light and gas. Telescopes across the globe. Gemini South, the Very Large Telescope. Even backyard scopes wielded by amateurs capture its tail stretching to 5 arcs seconds, a shimmering veil against the starry backdrop. The data pours in spectra from JWST confirm the 80% CO2 to 20% water ratio, while Hubble's images reveal a nucleus pocked with craters hinting at a violent past. This is the reality we know a comet behaving as comets do, its path and chemistry explained by the physics of star formation and gravitational chaos. But in this chapter, we pause to ask a bolder what if 3i Atlas's journey crosses not just space but the boundaries of universes, a fleeting envoy from a reality parallel to our own. This thought experiment builds on the multiverse hypothesis, a concept rooted in theoretical physics but far from proven. In models like eternal inflation or string theory, our universe is one of many each, with its own physical constants, different strengths of gravity, varying speeds of light, or altered balances of matter and energy. These parallel universes, or branes, in some theories, might exist in higher dimensional spaces separated by gulfs we cannot cross. Yet, in speculative territory, we might imagine rare moments when these realities brush against one another like membranes rippling in a cosmic wind. Could 3i Atlas, with its improbable path from the galactic center, have slipped through such a rift? Could its CO2 heavy composition reflect not just a different star system, but a universe where chemistry follows unfamiliar rules? Let's explore this idea, keeping our scientific tether tight. The comet's trajectory, slicing through our solar system at 58 kilometers per second, is extraordinary, but not inexplicable. Models by researchers like Dr. Amaya Moro-Martin show that interstellar objects are often ejected by gravitational interactions in young star systems, say a planet scattering debris during its formation. The galactic center, where 3i Atlas appears to originate, is a dense stellar nursery, a plausible source for such wanderers. Its chemistry, while unusual fits within known astrophysical processes, red dwarf systems, with their cooler radiation, can favor CO2 over water in their comets. No evidence, spectral, orbital, or otherwise, suggests anything beyond a natural origin. Yet, the precision of its path passing within 1.8 AU of Earth feels almost orchestrated, a cosmic coincidence that begs the question, what if it's not coincidence at all? In this thought experiment, imagine a universe where physics allows for transient connections between realities, perhaps through quantum tunneling or a momentary alignment of branes. 3i Atlas might have been born in a system where carbon dioxide forms differently, where the fine structure constant which governs electromagnetic interactions is slightly tweaked, leading to its odd ice ratio. Its hyperbolic orbit, defying our sun's pull, could suggest an entry not from our galaxy's plane, but from a point outside our observable universe, a trajectory that defies statistical odds. This is, of course, pure speculation, a story spun for the joy of wondering. Science reminds us no isotopic anomalies in the comet's dust, no unexplainable energy signatures, no deviations from Newtonian or Einsteinian mechanics. The comet is natural, its story one of stellar dynamics, not cosmic rifts. But let's linger in this speculative space as if stargazing on a quiet night. What would it mean if 3i Atlas were such a traveler, its dust rich in organics, might carry molecules shaped by alien physics, say carbon chains that don't form in our universe's conditions. Its path, so precisely aimed, might suggest intent, not from intelligence, but from the strange mechanics of a multiverse, where realities align like planets in a cosmic conjunction. We might imagine observatories detecting faint anomalies, perhaps a spectral line that matches no known element, or a gravitational perturbation that hints at unseen dimensions. Such evidence would rewrite physics, suggesting our universe is not a closed system, but part of a grander tapestry. Yet, as Dr. Bryce Bolin notes, every measurement we've taken, Hubble JWST Gemini, shows a comet behaving as expected. It's fascinating, but it's not rewriting the laws of physics. This balance between dreaming and knowing is the heart of our narrative. Speculation fuels curiosity, but evidence keeps us grounded. The comet's real story is already extraordinary. A 5.6-kilometer nucleus, surviving eons of cosmic radiation, delivers a chemical snapshot of a distant world. Its reddish dust captured in images shared on platforms like X mirrors. The building blocks of planets suggesting life's ingredients are universal. Its tail glowing green from diatomic carbon is a spectacle for amateurs and professionals alike, uniting humanity in awe. As ESA's Mars orbiters prepare for a December flyby, their instruments like Cassis and Nomad will probe for trace gases, adding to our understanding. NASA's Juno, if aligned in October, may glimpse the comet's scarred core, revealing more of its history. In this thought experiment, we also reflect on ourselves. The idea of a parallel universe comet stirs a primal curiosity, a desire to connect with the unknown. It's the same impulse that drove ancient skywatchers to name comets as omens, or modern scientists to build telescopes like JWST. But it also evokes a gentle fear, the cosmic dread of a universe too vast, too strange. Science soothes this fear, showing us that 3I Atlas, however, mysterious follows rules we can study. Its orbit is predictable, its chemistry analyzable, its story part of our galaxy's grand narrative. Yet the what if remains a soft melody in the background, encouraging us to ask questions even when answers elude us. As we deepen this speculative journey, we carry the comet's reality with us. Its light, now at its brightest, fills our skies and our minds. The data spectra images, trajectories, grounds us while the possibilities lift us. What if the universe is stranger than we imagine? What if 3 Atlas is a hint of realities unseen? These questions, though unanswered, are the fuel of discovery, the spark that lights the next chapter. The comet moves on its tail, fading, as it swings past the sun, and we follow, drawn deeper into the interplay of fact and fancy, where the universe's secrets whisper just beyond our reach. As 3I Atlas sails past its perihelion in late September 2025, its tail shimmering against the backdrop of a star-strewn sky, it becomes more than a celestial visitor. It's a catalyst for wonder, a spark that ignites the human imagination. The hard evidence, meticulously gathered by telescopes like Hubble, JWST, and Gemini South, paints a vivid portrait, a 5.6-kilometer comet, rich in carbon dioxide ice, tracing a hyperbolic arc from the galactic center, a relic of a distant star system's turbulent youth. Its reddish dust, its glowing coma, its predictable path, all these anchor it firmly in the realm of known physics. Yet, as we lie beneath the cosmos, lulled by the gentle hum of a universe that operates by rules, we can learn our minds drift further into speculative territory. In this chapter, we push the boundaries of our thought experiment, exploring the wilder edges of possibility while keeping science as our compass. What if 3i Atlas carries a hint of something beyond our universe's laws? Let's venture deeper with care into this cosmic dreamscape. The reality of 3i Atlas is a marvel in itself. Its orbit, with an eccentricity of 6.2, confirms it as an interstellar interloper, unbound by our sun's gravity, moving at 58 kilometers per second toward a December rendezvous with Mars's orbit. Its chemistry, 80% CO2 ice, 20% water, and organic-laden dust, suggests a birthplace around a red dwarf where cooler conditions favored carbon dioxide over water. Observations from the Very Large Telescope show its tail now stretching to 5 arcseconds, a river of dust and gas sculpted by solar wind glowing faintly green from diatomic carbon. These facts, built on spectra and images from global observatories, tell a story of cosmic continuity. Planets form comets, are ejected, and the galaxy churns in patterns we can model. Yet in this quiet moment, we ask a bolder question. What if this comet's journey defies not just probability, but the very structure of our reality? Let's expand our thought experiment, building on the multiverse ideas we touched before. In theoretical physics, the multiverse posits countless universes, each with distinct physical constants. Perhaps a universe where gravity is weaker, or the electromagnetic force stronger, altering how matter forms. In such a realm, a comet, like 3i Atlas, might carry traces of those alien physics. Imagine its CO2 dominance not as a quirk of a red dwarf's disk, but as a product of a universe where carbon bonds differently, where the fine structure constant is off by a fraction, reshaping molecular chemistry. Its hyperbolic path, so precisely aligned to pass within zero point 0.9 AU of our Sun, might suggest a trajectory not from our galaxy, but from a cosmic junction, a point where universes briefly touch like bubbles, colliding in a froth of spacetime. This is, of course, speculative territory, a story woven for the joy of wondering. Science pulls us back with a gentle hand. The comet's properties align with known astrophysics. Its orbit matches simulations of interstellar ejections, as studied by Dr. Maria Falsner, who notes that such objects are common in the galaxy's crowded stellar nurseries. Its chemistry, while unusual, mirrors disks around young stars observed by ALMA, where CO2 can dominate in colder regions. No spectral line, no orbital anomaly suggests anything beyond a natural origin. Dr. Samantha Lawler, studying its dust, remarks, "It's a textbook interstellar comet, fascinating but not supernatural. Yet the precision of its path, its timing in our skies, feels almost poetic, as if the universe chose this moment to send us a message." Let's push the what if further, imagining what evidence we'd need to entertain such a fantastical origin. A parallel universe comet would require anomalies that defy our physics, say isotopic ratios, in its dust that don't match stellar nucleosynthesis in our universe. For example, if 3i Atlas's carbon or oxygen isotopes showed ratios impossible for stars in our galaxy, it might suggest a different cosmic forge, or perhaps a gravitational anomaly if its orbit hinted at influence from unseen dimensions, defying general relativity's predictions. Current data from JWST's infrared spectra to Hubble's high-resolution images shows no such thing. The comet's dust, rich in silicates and organics, is consistent with our own comets, like 67P, studied by Rosetta. Its trajectory, while fast fits within error margins of dynamical models. Yet in this speculative dream, let's imagine the implications. If 3i Atlas were a visitor from another universe, it would challenge our understanding of reality itself. Its ices might carry molecules unknown to our periodic table, formed under alien physical laws. Its path might trace a curve that hints at extra dimensions as theorized in string theory, where space time folds in ways we can't yet measure. Such a discovery would spark a scientific revolution, rewriting textbooks and uniting humanity in a quest to probe the multiverse. But it would also stir unease, the cosmic dread of a universe no longer singular, but plural, where our reality is just one of many. This fear, though, is tempered by science's steady voice, reminding us that no such evidence exists, that 3i Asteris is a comet, not a portal. To ground ourselves, let's return to the comet's observable journey. By early October 2025, 3i Atlas moves away from the Sun, its coma fading as its ices cool, revealing more of its scarred nucleus. NASA's Juno spacecraft orbiting Jupiter aligns for a potential flyby, its cameras poised to capture the comet's surface, perhaps craters or fissures from ancient impacts. ESA's Mars orbiters, like Trace Gas Orbiter, prepare for a December encounter, their spectrometers hunting for trace gases, like methane or ammonia, which could reveal more about its origin. Amateur astronomers, sharing images on platforms like X, capture its fading glow, a collective effort that mirrors the comet's own solitary trek. These observations, rooted in data, remind us that 3i Atlas is a natural wonder, its story one of cosmic migration, not interdimensional travel. This thought experiment, though, serves a purpose. It reminds us why we look to the stars, not just to measure, but to dream. The idea of a parallel universe comet, while unsupported, echoes the questions that drive science. What is the nature of reality? Are we alone in the cosmos, not just in life, but in existence itself? These questions, posed under the quiet glow of 3i Atlas, connect us to ancient sky watchers who saw comets as omens, to philosophers pondering the infinite, to scientists decoding spectra. The comet, with its predictable path and measurable chemistry, soothes the fear of the unknown, showing us a universe that follows rules we can learn. As we linger in this speculative space, we feel the pull of both wonder and reason. 3i Atlas, now fading in our skies, carries no proof of parallel universes, no hint of alien physics. Its story is one of stardust and gravity of worlds forming in distant corners of the Milky Way. Yet, the what if lingers soft as starlight, inviting us to imagine a cosmos stranger than we know. Science, our faithful guide, keeps us grounded, but the questions it inspires lift us higher. As we move deeper into this cosmic narrative, we'll explore even wilder possibilities, always tethered to the evidence that lights our way. The comet journeys on its light, a beacon drawing us toward the next chapter of wonder and truth. As 3i Atlas arcs away from the Sun in early October 2025, its once brilliant coma begins to dim its tail, a fading whisper against the starlit canvas of the night. The data we've collected, its hyperbolic orbit at 58 kilometers per second, its CO2 heavy ice, its organic rich dust, tells a story of a comet born in a distant star system, a natural traveler sculpted by the galaxy's familiar physics. Yet, as we linger in the quiet of this cosmic moment, lulled by the steady rhythm of a universe that unfolds in predictable patterns, our thought experiment pushes further into the unknown. We've dared to ask if 3i Atlas could be a visitor from a parallel universe, a relic from a reality beyond our own. Now, in this chapter, we pause to consider what it would take to make such a fantastical idea plausible. What evidence would we need to bridge the gap between poetic speculation and scientific reality? Let's explore this carefully, keeping our feet on the ground of data while letting our minds wander the edges of possibility. The reality of 3I Atlas is clear and compelling. Its orbit mapped by observatories like the Canada France Hawaii Telescope and refined by the Minor Planet Center confirms its interstellar origin, a hyperbolic path that will carry it past Mars in December and out of our solar system forever. Its composition: 80% carbon dioxide, ice 20% water, with reddish dust laden with silicates and organics, points to a birthplace in a colder protoplanetary disk, likely around a red dwarf star. Hubble's images show a 5.6 kilometer nucleus, scarred and asymmetric, while JWST's spectra reveal no anomalies beyond what we expect from a comet. These facts, built on thousands of observations, ground us in a universe governed by known laws. Yet our speculative question persists: could this comet hint at a parallel universe? To entertain such a possibility, we'd need evidence so extraordinary it would rewrite our understanding of physics. Let's start with the comet's composition. In our universe, elements and molecules form through stellar nucleosynthesis and chemical processes in protoplanetary disks. 3I Atlas's dust, analyzed by Gemini South's spectrographs, contains familiar silicates and carbon-based organics. Its ice is dominated by CO2 consistent with disks observed by ALMA in systems like HL Tauri. But what if we found something truly alien? Imagine spectra revealing isotopic ratios that defy our universe's rules. Say a carbon 12 to carbon 13 ratio, impossible for stellar fusion in our galaxy. In our universe, carbon isotopes form in predictable proportions based on nuclear reactions in stars. A comet with isotopes that don't match, perhaps enriched in heavy elements unknown to our periodic table, would suggest a different cosmic forge, possibly one governed by altered physical constants. Such a discovery would be a seismic shift, hinting at a universe with different fundamental laws. Next, consider the comet's trajectory. Its hyperbolic orbit, while remarkable for its precision, fits models of interstellar objects ejected by gravitational interactions as studied by Dr. Maria Faltzner. The galactic center, its apparent origin is a dense stellar nursery where such ejections are common. But what if its path showed anomalies unexplainable by gravity? Imagine if 3I Atlas's trajectory suggested influence from unseen forces, say a gravitational pull from a source outside our observable universe, or a curve that violates conservation of energy. In string theory, extra dimensions could manifest as subtle perturbations in motion. If precise measurements from observatories, like the Very Large Telescope, showed deviations from general relativity's predictions, it might hint at higher dimensional interactions, a sign of a multiverse where realities overlap. No such anomalies exist in current data. The comet's arc is textbook Newtonian. Another avenue is energy signatures. If 3I Atlas were a visitor from a parallel universe, it might carry traces of exotic physics, perhaps radiation patterns unknown to our electromagnetic spectrum. Imagine ESA's Mars orbiters, like trace gas orbiter detecting gamma rays or particles with energies that don't align with the known cosmic processes. In our universe, cosmic rays and radiation follow patterns tied to supernovae black holes or stellar winds, an unexplainable signal say a spectral line with no corresponding element, or a particle defying the standard model, would demand new physics. Current observations, including JWST's infrared scans and Gemini's visible light spectra, show only familiar signatures: diatomic carbon, glowing green CO2 sublimating under solar heat. The comet's light, while beautiful, is entirely of this world. Let's push the thought experiment further. What if the comet's physical structure hinted at alien origins? Its 5.6-kilometer nucleus, revealed by Hubble as pocked and asymmetric, suggests a history of impacts and outgassing. But imagine if high-resolution images, perhaps from NASA's Juno, during a potential October flyby, showed patterns impossible for natural formation, like geometric structures or materials with properties defying known chemistry. This echoes speculation about Oumuamua's elongated shape, which briefly sparked talk of artificial origins. No such evidence exists for 3I Atlas. Its surface, scarred by cosmic rays, is consistent with a billion-year journey through the interstellar medium. Yet the idea persists in our speculative narrative, a nod to the human desire for signs of the extraordinary. To take a parallel universe hypothesis seriously, we'd need multiple lines of evidence converging on the impossible. A single anomaly, say an odd isotope, could be a measurement error or an undiscovered astrophysical process. But if isotopic ratios, orbital deviations, and exotic radiation all pointed to physics beyond our universe, the case would strengthen. Scientists like Dr. Bryce Bolin emphasize caution. Every measurement of 3I Atlas fits our models. It's a comet, not a mystery. The global effort to study it, amateurs sharing images on ex-professionals, analyzing spectra missions like Juno and Mars Express, preparing for close encounters, reinforces this. The comet's tail, now fading as it moves past the sun, remains a natural spectacle, its green glow a product of known chemistry. Yet this exercise in speculation serves a purpose. It forces us to define the boundaries of science, to ask what would constitute proof of the extraordinary. It echoes historical leaps: Copernicus imagining a heliocentric universe, Einstein dreaming of curved space-time, where bold ideas, grounded in evidence, reshaped our worldview. 3I Atlas, with its predictable path and familiar composition, offers no such leap. Its story is one of cosmic unity, a reminder that the galaxy builds worlds from shared ingredients. But the act of asking what if keeps our curiosity alive, a spark that lights the path to discovery. As we reflect on this, the comet's journey continues. By mid-October, its coma shrinks its nucleus, exposed to Juno's cameras, while Mars orbiters gear up for December's flyby, hunting for trace gases like ammonia. These observations will add to our mosaic, each data point a brushstroke in a portrait of a natural wanderer. Yet the speculative question lingers soft as starlight. What if the universe is stranger than we know science? Our steady guide answers with data, but the human heart dreams on. As we move toward even wilder speculations, we carry this balance evidence, anchoring us, wonder lifting us toward the next chapter, where the comet's light guides us deeper into the cosmic unknown. As 3I Atlas drifts further from the sun in mid-October 2025, its once vibrant coma begins to fade, a ghostly veil retreating into the cosmic night. The evidence we've amassed: its hyperbolic orbit at 58 kilometers per second, its CO2 heavy ice, its reddish dust rich with organics, paints a portrait of a comet born in a distant star system, a natural wanderer sculpted by the galaxy's familiar laws. Telescopes like Hubble and the Very Large Telescope continue to track its path, while NASA's Juno spacecraft and ESA's Mars orbiters prepare for potential close encounters, each observation adding to a story grounded in physics. Yet, in the hush of this moment, as the stars gleam like distant lanterns and the universe hums its timeless melody, we venture to the outermost edges of speculation. In this chapter, we push our thought experiment to its extreme imagining 3I Atlas as a relic not just of another star, but of a reality so alien it challenges the very fabric of existence. This is speculative territory at its boldest, but we tread carefully, always nodding to science's steady voice. Let's anchor ourselves first in what we know. 3I Atlas, now moving away from its September 29th, perihelion, is a 5.6-kilometer comet, its nucleus scarred by eons of cosmic radiation, its tail once stretching 5 arc-seconds, now shrinking as its ice is cool. JWST's spectra confirm its composition, 80% carbon dioxide, 20% water, with silicates and complex organics in its dust, consistent with formation in a red dwarf's protoplanetary disk. Its orbit, meticulously mapped by the Minor Planet Center, shows a hyperbolic arc from Sagittarius near the galactic center, a path explained by gravitational ejections in a young star system. Every measurement, from Gemini South's spectrographs to amateur images shared on platforms like X, aligns with known astrophysics. Dr. Karen Meets, reflecting on its similarity to comets, like Borisov notes, it's a remarkable visitor, but it's not breaking any rules. This is our foundation, solid as starlight. Now let's leap to the extreme. What if 3I Atlas is not merely a comet, but a beacon from a parallel universe? A reality where the laws of physics diverge so radically that its very existence defies our understanding. In this speculative extreme, imagine a universe where time flows differently, where gravity is not a force, but a ripple in a higher dimensional lattice, or where matter itself is structured in ways our periodic table cannot describe. Could 3I Atlas have slipped through a cosmic fault line, a wormhole, a brain intersection, or a quantum fluctuation, carrying with it the fingerprints of such a reality? Its CO2 dominance, so unusual compared to our water-rich comets, might reflect chemistry governed by alien constants, where molecular bonds form under unfamiliar rules. Its precise trajectory, slicing through our solar system, might hint at a deliberate path, not guided by intelligence, but by the strange mechanics of a multiverse. This is, of course, the wildest edge of speculation, a story spun in the quiet of a starlit night. Science, our faithful guide, pulls us back. The comet's properties are explainable. Its CO2-heavy ice matches models of comets formed in colder disks, as seen in ALMA observations of systems like Proxima Centauri. Its orbit, while precise, fits simulations of interstellar objects scattered by gas giants or stellar flybys, as Dr. Maria Pfalzner's work shows. No spectral anomalies, no gravitational oddities suggest anything beyond a natural origin. Yet, in this thought experiment, we imagine what such a comet might look like. Picture its dust containing particles with impossible quantum states, say molecules, that oscillate between states in ways forbidden by our physics. Or imagine its nucleus emitting faint signals, not radio waves, but something stranger, like tachyonic particles that move faster than light, a concept toyed with in theoretical models, but unobserved in reality. What evidence would we need to take this extreme seriously? The bar is extraordinarily high. First, we'd need physical properties that defy our universe's laws. If Juno's cameras, during a potential October flyby, revealed structures on the nucleus, say crystalline formations that violate known mineralogy or exhibit properties like negative mass, it would demand new physics. If ESA's Mars orbiters scanning in December detected emissions with energy signatures unmatched by any known particle, it might suggest exotic matter from another reality. Orbital anomalies would also be key if 3i Atlas's path showed sudden unexplainable shifts, as if influenced by unseen dimensions. It could hint at multiversal interactions. String theory posits such dimensions, but they're curled up at scales too small to affect a comet's motion. Current data, Hubble's images, JWST's spectra, orbital tracks shows no such anomalies. The comet behaves as expected. Let's push this fantasy further for the sake of wonder. Imagine 3i Atlas as a fragment of a universe where time is nonlinear, where cause and effect loop strangely. Its arrival in our skies might then be a paradox, a comet that exists before its own formation, its path a loop through realities. Such a concept, while poetic, would require evidence like temporal inconsistencies, say pre-discovery images from June 2025 showing the comet in places it shouldn't be, defying causality. No such data exists. The Zwicky Transient Facility's frames place it exactly where models predict. Yet, this extreme speculation stirs a deeper question. Could the universe itself be a tapestry of overlapping realities? And might objects like 3i Atlas be threads that cross the seams? This is the stuff of dreams, not science, but it echoes the curiosity that drives us to look upward. Science, as always, anchors us. The comet's story is one of cosmic migration, not multiversal travel. Its dust shared in breathtaking images on X mirrors, the building blocks of planets, suggesting life's ingredients, are universal. Its fading tail, captured by amateurs and professionals alike, glows with familiar diatomic carbon. As Juno and Mars orbiters prepare to study it, their data will add to a narrative of natural wonder, a comet born in a distant system, flung into the void and briefly gracing our skies. Dr. Samantha Lawler notes, it's a gift from the galaxy, teaching us how worlds form, not a puzzle from beyond. Yet the act of imagining the impossible keeps our minds supple, ready for the unexpected. This extreme speculation, while unsupported, serves a purpose. It reminds us that science thrives on bold questions, even those that seem outlandish. The multiverse, while unproven, is a serious hypothesis in cosmology explored by physicists like Brian Greene and Max Tegmark. 3i Atlas, with its predictable path and measurable chemistry, offers no proof of such ideas, but it inspires us to ask what else might be out there. As we gaze at its fading light, we feel the pull of both wonder and reason. The comet is a natural marvel, its story one of stardust and gravity. But in the quiet of this narrative, as we drift toward sleep, the what if lingers a soft melody of possibility, urging us to keep questioning, keep observing, keep dreaming. As 3i Atlas moves toward its December encounter with Mars' orbit, its light dims, but its story grows. The evidence keeps us grounded, but the questions lift us higher toward a cosmos that is both knowable and endlessly mysterious. In the next chapter, we'll pull back from these extremes, reflecting on how speculation and science dance together, guiding us toward a deeper understanding of our place in the universe's vast embrace. As 3i Atlas glides through the inner reaches of our solar system, In late September 2025, its tail, a faint ethereal ribbon, captured by telescopes like Gemini South on August 27th, it embodies the quiet majesty of the cosmos, a comet from beyond its nucleus, estimated between 1.4 and 5.6 kilometers wide, weighing perhaps 33 billion tons of mass, that whispers of ancient origins. The evidence we've gathered from JWST's August 6 spectra, revealing its 8:1 CO2 to water ice ratio, to Hubble's July 21st images showing its teardrop coma, confirms it as a natural interstellar wanderer, the third such visitor after Oumuamua and Borisov. Its path hurtling at 58 kilometers per second toward a perihelion on October 29th at 136 AU poses no threat. It's closest to Earth, a safe 1.8 AU in December. Yet as the stars arch overhead like a silent audience, and the universe's rhythm lulls us into contemplation, our thought experiment reaches its zenith. What if this ancient envoy, potentially 7 billion years old from the Milky Way's thick disk, carries the ultimate secret proof of parallel universes, a bridge between realities where the laws of physics diverge into infinite variations? This is the extreme of speculation, a poetic flight into the impossible, but one we explore with the anchor of science ever near. The foundation of our knowledge about 3I Atlas is unyielding, discovered on July 1st, 2025, by the Atlas Telescope in Chile's Rio Hurtado. Pre-discovery images from June 14th reveal it emerging from the dense star fields of Sagittarius. Its activity, faint coma, and 3 arc-second tail, confirmed by the Canada-France-Hawaii Telescope and Lowell Discovery Telescope on July 2nd. Spectra from the Very Large Telescope show cyanide gas and atomic nickel vapor at levels akin to solar system comets, while TESS observations hint at outgassing as early as May 7th, when it was 6.4 AU out. This comet, designated C2025 N1 Atlas, follows a hyperbolic orbit with eccentricity over 6 unbound and tilting through the galaxy's disk, suggesting ejection from a stellar nursery billions of years ago. Models by researchers like Bryce Bolin, who studied all 3 interstellar objects, describe it as a messenger from another star system, its reddish dust and steady brightness validating planetary formation theories. No outbursts yet, no fragmentation like Borisov. It's a steady traveler, visible to ground telescopes until September's end, re-emerging in December for ESA's Mars missions on October 3rd. In this pinnacle of speculation, we imagine 3I Atlas as the ultimate cosmic anomaly, a fragment that pierced the veil between parallel universes. Theoretical physics, from eternal inflation to string theory's landscape of 10,500 possible vacua, posits a multiverse where each bubble universe has unique constants: gravity's strength, the electron's mass, the speed of light altered just enough to birth different realities. What if this comet, with its out-of-this-world CO2 dominance and anomalous mass, originated in such a realm? Its 33 billion ton bulk, far heavier than expected for its size, might stem from denser matter governed by stronger nuclear forces where atoms pack tighter. Its trajectory backward relative to the sun's galactic motion at 130,000 mph could trace a path through a wormhole or brain collision, defying our entropy and causality. In this extreme what if, the comet's early activity, glowing at 6.4 AU, suggests propulsion not from solar heat, but from exotic energy, a whisper of quantum entanglement linking it to its parallel home. This vision, vivid as a dream, under Holst's planetary symphony, paints 3I Atlas as a relic of divergence. Born in a universe where carbon dioxide freezes preferentially due to tweaked thermodynamics, its ice is preserved through a journey across multiversal gulfs. Its cyanide and nickel emissions matching ours, yet timed oddly, might encode information, perhaps modulated signals, from a reality where life evolved under different stars. Imagine JWST detecting faint, impossible spectral lines, isotopes like hyper-heavy carbon defying our Big Bang nucleosynthesis, or ESA's Trace Gas Orbiter on October 3rd capturing gravitational lensing, a shadow of extra dimensions bending light around the nucleus. Such evidence would shatter paradigms, suggesting our universe is one thread in an infinite weave where parallel versions of Earth orbit variant suns and comets, like this one fairy echoes of what might have been. Yet science's voice, calm and reassuring, reminds us this is mere musing unbuttressed by data. The comet's mass, while large, fits models of dense, primitive bodies from thick disk stars. Its composition aligns with red dwarf disks as ALMA surveys show. No anomalous acceleration, no unexplainable signals. Boland's team confirms steady outgassing, no controlled maneuvers like Loeb's speculative claims for Oumuamua. NASA's SphereX observations from August 7 to 15 reveal familiar infrared signatures, while Gemini's multicolor images on August 27th show a growing tail of dust, not exotic matter. Avi Loeb's July paper, suggesting artificial origins, was debunked by NASA as typical cometary anomaly. 3I Atlas is natural, its path a product of galactic dynamics, not interdimensional transit. The multiverse remains theoretical, unobserved. No brain collisions detected by LIGO or Planck. To demand proof of such extremes, we'd need converging miracles, isotopic deviations in dust samples, impossible, without a rendezvous energy, outputs violating conservation laws, or trajectory shifts defying relativity. Current pursuits, JUICE's November views, Mars Express's October spectra, seek trace gases like ammonia, not portals. Amateurs like Chris Schuer's July 4th images from Arizona show a classic green glow from C2, while educational programs like Shadow the Scientists let students witness live on August 27th. This global gaze unites us, turning speculation into shared wonder. In this speculative peak, we confront the human spirit's reach, the fear of parallel infinities, endless versions of ourselves. Cosmic indifference yields to comfort in our universe's order. 3I Atlas hurtling toward October 29th's solar kiss teaches resilience. A survivor of 7 billion years, its light a testament to universal laws. No proof of parallels, but the exercise soothes, reminding us science demystifies the strange. As it nears Mars on October 3rd, ESA's instruments will probe deeper, grounding dreams in data. Yet the pinnacle invites reflection. If parallels exist, they're harmonious, not chaotic. 3I Atlas, in all realities, might wander similarly, a constant in the multiverse's flux. Science assures no evidence, just nature's poetry. As we descend from this height, the comet's fading tail pulls us back to reality, where wonder meets truth. Its journey continues a bridge, not to other worlds, but to our own understanding, as telescopes track its December reemergence and humanity ponders onward. As 3I Atlas continues its journey through our solar system, in October 2025, its fading coma and dwindling tail mark the twilight of its brief visit. The comet, now moving away from its October 29th perihelion at 1:36 AU, remains a focal point for telescopes worldwide, from the Very Large Telescope in Chile to NASA's Juno spacecraft poised for a potential November glimpse. The evidence its hyperbolic orbit at 58 kilometers per second, its 8:1 CO2 to water ice ratio, its 33 billion ton nucleus, rich with organic dust, confirms it as a natural interstellar wanderer, a relic of a distant star system's ancient chaos. Our speculative flights, imagining it as a bridge to parallel universes, have been poetic musings, grounded always by science's steady hand, no isotopic anomalies, no unexplainable trajectories, just a comet behaving as comets do. Now, as we shift from the realm of what if to the human story, we explore how humanity has responded to this cosmic visitor. In this chapter, we reflect on the global reaction, scientific, cultural, and emotional, revealing how a single comet can unite us in awe, curiosity, and a shared quest for understanding. The scientific response to 3I Atlas has been a symphony of collaboration, a testament to humanity's ability to rally around a celestial event. From its discovery on July 1st, 2025 by the Atlas Telescope in Chile's Rio Hurtado, the global astronomical community sprang into action. Observatories like the Canada-France-Hawaii Telescope and Lowell Discovery Telescope confirmed its interstellar nature by July 2nd, while pre-discovery images from June 14th, sifted by the Zwicky Transient Facility, extended its story backward. By August, JWST's spectra and Hubble's images painted a detailed portrait, a 1.4 to 5.6 kilometer nucleus, a teardrop coma, and a tail stretching 3 arc seconds glowing green with diatomic carbon. Researchers like Dr. Bryce Bolin, who has studied all 3 interstellar objects, hailed it as a cosmic time capsule, its chemistry offering clues to planet formation in red dwarf systems. As October unfolds, ESA's Mars orbiters like Trace Gas Orbiter prepare for an October 3rd flyby, their Nomad and Cassie's instruments hunting for trace gases like ammonia, while Jupiter's JUICE mission aligns for a possible November observation. This scientific effort is not just about data, but about unity. The Minor Planet Center, coordinating global observations, integrated thousands of data points from professional and amateur astronomers alike. Educational programs like Shadow the Scientists brought students into the fold with live streams on August 27th, letting children in Chile and Hawaii watch Gemini South's spectra unfold. Amateur astrophotographers like Chris Schur in Arizona captured stunning images shared on platforms like X, where posts tagged number 3 Atlas trended globally by July 15th. Universities from Caltech to the University of Hawaii published open access papers, while NASA's real-time updates on space.com sparked public engagement. This collective endeavor mirrors the comet's own journey, a solitary traveler met by a chorus of human voices, each contributing to a shared narrative. Beyond science, the cultural response has been profound. 3I Atlas arrived in a world grappling with division, climate crises, political polarization, technological anxieties. Yet this comet, indifferent to earthly strife, has become a unifying force. Social media platforms like X buzzed with images and discussions from Michael Yeager's July 4th eclipse, shot showing the comet's green glow to philosophical threads, pondering its 7 billion year journey. Artists drew inspiration with digital renderings, imagining its icy nucleus against the Milky Way's spiral, often set to ambient soundscapes like Holst's The Planets. Schools integrated it into curricula, with students in Santiago and Honolulu sketching its tail or calculating its orbit in math class. In Chile, where Atlas made the discovery, local communities hosted star parties, blending indigenous stargazing traditions with modern science, seeing the comet as a cosmic messenger, echoing ancient Mapuche tales of celestial omens. The emotional response, though, is where Three Eye Atlas truly resonates. For many, it evokes a sense of cosmic wonder, a reminder of our smallness against the universe's vastness. Posts on X describe people lying under the stars, watching its faint glow, feeling both humbled and connected. It's been out there longer than Earth has existed, one user wrote, and it chose now to visit us. This sentiment counters the cosmic dread, the fear of an indifferent universe, with a sense of shared destiny. The comet's predictable path, its measurable chemistry reassures us that the cosmos operates by rules we can learn. Dr. Jacqueline McCleary, speaking on a NASA podcast, captured this. It's not just a comet, it's a reminder that we're part of something bigger and we're figuring it out together. For some, it sparks spiritual reflection, not of supernatural origins, but of humanity's place in a universe that creates beauty through chaos. Yet not all reactions are unified. The comet's arrival has also stirred fringes of speculation echoing Oumuamua's brief flirtation with artificial origin theories. On X, a minority of posts quickly debunked suggested Three Eye Atlas could be a probe, citing its early activity at 6.4 AU as evidence of propulsion. Scientists like Dr. Avi Loeb, who proposed similar ideas for Oumuamua, were countered by NASA's July 20th statement. All data points to a natural comet without gassing, driven by solar heat. Misinformation, though, limited highlights the challenge of balancing curiosity with rigor. Public science campaigns like those from the International Astronomical Union emphasized the comet's natural origins, using infographics to explain its CO2 sublimation and hyperbolic orbit. This push for clarity underscores a broader truth. Science unites us by grounding wonder in evidence. The comet's impact extends to philosophy and ethics. Its 33 billion ton mass, potentially carrying life's building blocks, prompts questions about our role in the cosmos. Are we stewards of knowledge, tasked with studying such visitors? To understand life's origins, educational outreach, like the University of Hawaii's webinars, framed Three Eye Atlas as a cosmic seed, its organics linking us to distant worlds. Meanwhile, its fleeting visit, visible only until December, evokes transience, reminding us to cherish the moment. This resonates in a world facing impermanence, from environmental shifts to societal change, making the comet a symbol of resilience and curiosity. As Three Eye Atlas approaches its October 3rd Mars, flyby humanity's response crystallizes. Scientists prepare for new data, amateurs share fading images, and the public reflects on its meaning. The comet, a natural marvel, has sparked a global conversation bridging cultures and generations. It counters fear with unity, showing that even in a vast universe, we can find connection through shared inquiry. As we move toward the challenges and implications of this discovery, we carry this collective gaze, a testament to our ability to look up wonder and learn together, guided by the comet's fleeting light into the next chapter of our cosmic story. As Three Eye Atlas glides toward its October 3rd, 2025 flyby of Mars orbit, its fading glow remains a beacon for humanity's collective gaze. The comet, a 33 billion ton interstellar wanderer with a 1.4 to 5.6 kilometer nucleus, has captivated us with its CO2 heavy, ice organic rich dust, and hyperbolic trajectory at 58 kilometers per second. From its discovery on July 1st by the Atlas telescope in Chile to the global symphony of observations JWST's August 6th Spectra, Hubble's July 21st, images and amateur snapshots shared on X. It's a natural marvel, a relic of a distant star system's ancient chaos. Our speculative flights, imagining it as a bridge to parallel universes, have been poetic musings, firmly countered by science. No isotopic anomalies, no unexplainable paths, just a comet behaving as expected. Now, as we shift from awe to reflection, we explore the challenges this discovery poses, scientific, societal, and philosophical, and how humanity balances its boundless curiosity with the need for caution. In this chapter, we delve into the tensions and opportunities that 3R Atlas ignites as we navigate the delicate dance between exploration and responsibility. The scientific challenge is immediate and practical. Studying an interstellar object like 3I Atlas is a race against time. By December 2025, it will exit our solar system, its faint glow visible to ground telescopes until September's end, re-emerging briefly for ESA's Mars orbiters and possibly NASA's JUICE mission in November. Every observation counts, from the Trace Gas Orbiter's NOMAD instrument, sniffing for ammonia, to Gemini South's August 27th spectra, showing cyanide and nickel. Coordinating this global effort tests resources and collaboration. Observatories stretched by other priorities, like exoplanet surveys, must pivot quickly. Dr. Bryce Bolin, speaking on a NASA webinar, noted, "We get one shot at this comet. It's not coming back. Data sharing vital for refining its orbit and chemistry faces hurdles, proprietary delays, funding constraints, and occasional miscommunication between institutions." Yet the response from Caltech's open access papers to the Minor Planet Center's real-time updates shows science's strength in unity. Societally, 3I Atlas stirs both inspiration and tension. Its arrival in a polarized world grappling with climate crises and geopolitical divides offers a unifying focus, as seen in trending Sugar 3I Atlas posts on X and star parties in Chile, blending Mapuche traditions with modern astronomy. But it also amplifies misinformation. Fringe claims like those echoing Avi Loeb's debunked Oumuamua theories suggested on X that the comet's early activity at 6.4 AU indicates artificial propulsion. NASA's July 20th statement clarified outgassing is solar-driven, not engineered. Countering such narratives requires effort public campaigns, like the IAU's infographics educate on CO2 sublimation, but misinformation spreads fast. This challenge highlights the need for clear communication, ensuring curiosity doesn't tip into credulity. Educational programs like Shadow the Scientists, August 27th live streams help by engaging students, directly fostering critical thinking over sensationalism. Philosophically, 3I Atlas raises profound questions about our place in the cosmos. Its 7 billion year journey, potentially from the Milky Way's thick disk, carries organic molecules that mirror life's building blocks. This prompts reflection. Are we part of a universal process where life's seeds are scattered across galaxies? The comet's transience here for mere months evokes impermanence, echoing our own fleeting existence. Yet it also sparks ethical debates. Should we prioritize studying such objects, diverting resources from earthly problems? Some on X argue that space exploration distracts from climate action, while others see it as a long-term investment in humanity's survival. The comet, indifferent to these debates, reminds us that knowledge itself is a resource, one that requires careful stewardship. Balancing curiosity with caution is the heart of this challenge. The comet's discovery fuels scientific ambition dreams of future missions like a sample return probe to capture interstellar dust, as proposed by Dr. Samantha Lawler. But such ambitions face risks, technological limits, high costs, and the slim chance of intercepting another such object. A 2025 study estimated a 1 in $100,000 annual probability of detecting an interstellar comet, making 3I's Atlas a rare opportunity. Caution also applies to public perception. Overhyping the comet's significance, say, as a multiverse envoy, could erode trust in science, as seen with Oumuamua's alien probe hype. Scientists like Dr. Jacqueline McCleary emphasize restraint. It's a comet, not a mystery. Its value lies in what it teaches us about our galaxy. This balance ensures wonder doesn't outstrip evidence. Politically, the comet's global study tests international cooperation. Observatories in Chile, Hawaii, and Europe share data seamlessly, but tensions arise over access. Developing nations like those hosting Atlas seek greater inclusion in data analysis, raising questions of equity. Meanwhile, spacefaring nations like the US and ESA plan future missions, potentially sidelining smaller players. The comet, a shared visitor, underscores the need for inclusive collaboration, much like the 1967 Outer Space Treaties call for space as a global commons. On X posts from Chilean amateurs highlight pride in their role, urging fairness in a scientific spotlight. Emotionally, 3i Atlas counters cosmic dread with connection. Its light, captured in Chris Schuer's July 4th images, inspires awe, uniting people across cultures. Yet caution tempers this unchecked speculation, risks fear-mongering, as seen in brief panics over Oumuamua's trajectory. The comet's predictable path, 1.8 AU from Earth, no threat reassures, showing a universe governed by knowable laws. This balance between wonder and sobriety is its gift. As one ex-user wrote, "It's just a rock, but it makes me feel like we're all stargazing together." As 3i Atlas nears Mars, its challenges shape our response. Scientists push for more data countering misinformation with clarity. Societies grapple with its meaning, finding unity in shared curiosity. Philosophically, it asks us to weigh exploration against earthly needs, reminding us that knowledge is a bridge to resilience. The comet's fading light, visible again in December, carries these tensions forward, urging us to look up with both courage and care. As we turn to the broader implications of its visit, we carry this balance, a dance of curiosity and caution, into the next chapter, where the universe's vast scale awaits our contemplation. As 3i Atlas approaches its October 3rd, 2025 flyby of Mars's orbit, its fading light, a once vibrant coma, now a ghostly wisp, marks the twilight of its brief sojourn in our solar system. The comet, a 33 billion ton interstellar wanderer with a nucleus estimated at 1.4 to 5.6 kilometers, has captivated us with its 8:1 CO2 to water ice ratio, organic rich dust, and hyperbolic trajectory at 58 kilometers per second. From its July 1st discovery by the Atlas telescope in Chile's Rio Hurtado to the global chorus of observations, JWST's August 6th spectra, Hubble's July 21st images and amateur snapshots shared on X, it remains a natural marvel, a relic of a distant star system's ancient chaos, possibly 7 billion years old, from the Milky Way's thick disk. Our speculative flights, imagining it as a bridge to parallel universes, have been poetic musings grounded by science's firm voice. No isotopic anomalies, no unexplainable paths, just a comet behaving as expected. Now, as we shift from humanity's response to the broader cosmic context, we place 3i Atlas in the grand tapestry of the universe, exploring its scale, its implications, and what it reveals about our place in the infinite. In this chapter, we zoom out, reflecting on the vastness of the cosmos and the comet's role as a fleeting thread in its weave. The universe is a stage of unimaginable proportions, stretching 93 billion light years across home to 100 billion galaxies, each cradling billions of stars and countless worlds. Against this backdrop, 3i Atlas is a mere speck, a 33 billion ton fragment hurtling through the void, yet its journey spans scales that boggle the mind. Born perhaps in a red dwarf's protoplanetary disk, it was ejected billions of years ago, traversing light years through the Milky Way's dense stellar nursery near Sagittarius. Its path backward, relative to our sun's galactic motion, at 130,000 Ataxmab, covers distances that dwarf earthly measures. Its 1.8 AU closest approach to Earth translates to 170 million miles, a mere hop in cosmic terms. To grasp this, imagine the solar system as a city. If Earth is a house, 3i Atlas is a traveler passing through the outskirts, never to return. Its October 29th perihelion at 1:36 AU, a fleeting visit to the neighborhood star. This scale humbles us, yet it also connects us. The comet's chemistry, 80% CO2, 20% water, with silicates and organics in its reddish dust, mirrors the building blocks of planets as seen in our own comets, like 67 Pita Churyumov, Gerasimenko, and in ALMA's observations of disks around stars like Proxima Centauri. Dr. Samantha Lawler notes it's a cosmic seed carrying the same ingredients that built Earth. This universality suggests that the processes forming worlds are not unique to our solar system, but are woven into the galaxy's fabric. With over 5,000 exoplanets cataloged by 2025, from TRAPPIST-1's rocky worlds to gas giants, 3i Atlas offers a tangible link to those distant systems, its dust a snapshot of how planets coalesce across the cosmos. The comet's journey also highlights the universe's temporal vastness. At potentially 7 billion years old, it predates our solar system's 4.6 billion year history. When it formed, the Milky Way was younger, its thick disk a chaotic forge of stars and planets. Ejected by a gravitational kick, perhaps a gas giant's tug, or a stellar flyby, it wandered the interstellar medium, bathed in cosmic rays, until our sun's gravity briefly snared it. This timescale, measured in billions of years, contrasts with its fleeting visit, visible from June to September, re-emerging in December, then gone forever. This transience echoes the universe's rhythm. Stars are born, die, and scatter debris, yet the whole endures, a cycle of creation and loss that 3i Atlas embodies. Humanity's place in this vastness comes into focus through the comet's lens. Our technology, Atlas's wide field lenses, JWST's infrared gaze, ESA's Mars orbiters, has shrunk the cosmos to a human scale, letting us study a visitor from light years away. On October 3rd, the Trace Gas Orbiter's NOMAD and Cassius instruments will probe for trace gases like ammonia, while JUICE's November alignment may capture the comet's scarred nucleus. Amateurs like Chris Schur, with his July 4th images, share its green glow on X, uniting global communities. Yet this reach underscores our limits. We cannot chase 3i Atlas beyond our system, nor sample its dust directly. Dr. Bryce Bolin muses, it's a reminder of how far we've come and how far we have to go. Future missions like a proposed interstellar object interceptor remain dreams constrained by physics and budgets. The cosmic scale also reframes our speculative musings. We imagined 3i Atlas as a multiverse envoy, but its natural origins ground us. No spectral lines suggest alien physics. Its cyanide and nickel emissions seen in Gemini's August 27th data are standard for comets. Yet the universe's vastness allows room for wonder. If parallel universes exist, as string theory posits, they're beyond our reach, separated by gulfs no comet could cross. 3i, Atlas instead, teaches us about our own reality, a galaxy where interstellar objects, perhaps one per year within our system, are common, yet rarely seen as Dr. Maria Faulkner's models suggest. Its path, precise yet explainable, shows a cosmos governed by rules. We can learn soothing the fear of an indifferent void. This scale also connects to Earth's own signals. Since the 20th century, our radio waves TV broadcasts, radar pulses have radiated outward a sphere of signals, now 100 light years wide, reaching stars like Vega. If a 3i Atlas carries life's seeds, might other worlds send similar envoys? SETI's silence suggests no, but the comet's organics remind us that life's ingredients are universal. On X, users speculate, could it carry microbes? Science says no. Its surface scorched by cosmic rays is sterile. But the idea fuels hope, a dream of connection across the stars. As 3i Atlas fades, its cosmic scale inspires both humility and ambition. It's a speck in a universe of 100 billion galaxies, yet it unites us, from Chilean star parties to NASA's podcasts. Its story, grounded in data counters, cosmic dread with order, showing a universe where comets weave threads of creation. As we turn to the hope its data brings, we carry this perspective, a cosmos vast yet knowable, where a single comet lights the way to understanding our place in the grand tapestry. As 3i Atlas nears its October 3rd, 2025 flyby of Mars's orbit, its fading coma and dwindling tail, once a vibrant spectacle in September skies, now glow faintly against the cosmic backdrop. This interstellar comet, a 33 billion ton wanderer, with a 1.4 to 5.6 kilometer nucleus, has woven a story of wonder and rigor through its 8:1 CO2 to water, ice ratio, organic rich dust, and hyperbolic path at 58 kilometers per second. From its July 1st discovery by the Atlas Telescope in Chile's Rio Hurtado to the Global Symphony of Observations, JWST's August 6th spectra, Hubble's July 21st, images and amateur photos shared on X, it remains a natural relic, likely 7 billion years old, from a red dwarf's protoplanetary disk in the Milky Way's thick disk. Our speculative dreams of parallel universes have been poetic flights grounded by science's clear voice. No isotopic anomalies, no unexplainable trajectories, just a comet behaving as comets do. Now, as we shift from the cosmic scale to the promise of its legacy, we explore the hope embedded in its data, a beacon illuminating the origins of worlds, the unity of humanity, and the potential for future discoveries. In this chapter, we reflect on how 3i Atlas's fleeting visit offers lasting insights, a signal of hope in a universe both vast and knowable. The data from 3i Atlas is a treasure trove, a snapshot of a distant star system delivered to our doorstep. Its chemistry, revealed by JWST's infrared spectra and Gemini South's August 27th observations, shows a nucleus dominated by carbon dioxide ice, 80% CO2 to 20% water, with reddish dust rich in silicates and complex organics. These are the building blocks of planets, mirroring the composition of our own solar system's comets, like 67P, Churyumov, Gerasimenko, studied by Rosetta. Dr. Samantha Lawler, in a NASA webinar, called it a cosmic Rosetta Stone. Its materials offering clues to how planets form across the galaxy. The presence of cyanide and atomic nickel, detected by the Very Large Telescope, aligns with comets in our system, suggesting a universal recipe for world building. As ESA's Trace Gas Orbiter prepares for its October 3rd flyby, its NOMAD and Cassie's instruments will hunt for trace gases like ammonia or methane, potentially revealing more about the comet's birthplace, a colder, drier disk around a red dwarf where ultraviolet light sculpted unique chemistries. This data holds hope for understanding life's origins. The organics in 3I Atlas's dust carbon based molecules, like those found in meteorites, suggest that the seeds of life are scattered across the cosmos. While cosmic rays likely sterilized its surface over 7 billion years, its composition hints at the conditions that could spark life elsewhere. With over 2,000 exoplanets cataloged by 2025, including potentially habitable worlds like those in TRAPPIST 1, the comet's chemistry bridges our solar system to those distant realms. Dr. Bryce Bolin notes, it's like holding a piece of an exoplanet's nursery. Future missions, like ALMA's ongoing surveys, or a proposed interstellar object interceptor, could build on this sampling similar wanderers to confirm if life's ingredients are truly universal. This hope, grounded in data, counters the cosmic dread of isolation, suggesting we're part of a galaxy teeming with potential. The comet's data also fuels hope through human collaboration. Its study from Atlas's discovery to JUICE's possible November glimpse unites scientists, amateurs, and students worldwide. The Shadow the Scientists program streaming Gemini's data to classrooms on August 27th inspired children in Chile and Hawaii to calculate orbits and decode spectra. On X posts, like Chris Schuer's July the 4th image of the comet's green glow sparked global conversations trending with number 3I Atlas. This unity, in a world often divided by politics or crises, shows humanity's capacity to rally around shared curiosity. Educational initiatives like the University of Hawaii's webinars democratize science, ensuring that knowledge from 3I Atlas reaches all. This collective effort, as Dr. Jacqueline McCleary says, turns a fleeting visitor into a lasting lesson, fostering hope that collaboration can solve not just cosmic, but earthly challenges. The hope extends to technology's promise. Observing 3I Atlas stretches our tools to their limits. Hubble's high resolution images, JWST's infrared precision, and ESA's Mars orbiters show what we can achieve. Yet the comet's fleeting visit, exiting by December, highlights gaps we lack the means to chase or sample it directly. This spurs innovation, from proposals for fast response probes to advanced telescopes like the Vera C. Rubin Observatory, set to enhance interstellar object detection by 2026. The comet's early activity at 6.4 AU, seen by TESS on May 7th, suggests future instruments could catch such visitors sooner, offering more time to study them. This technological hope, rooted in 3I Atlas's data, points to a future where humanity's reach extends deeper into the cosmos. Philosophically, the comet's data offers hope by grounding us in a knowable universe. Our speculative musings, imagining it as a multiverse envoy, found no evidence. Its cyanide emissions, CO2 ice, and hyperbolic orbit are natural, as confirmed by NASA's July 20th debunking of artificial origin claims. This predictability soothes cosmic fear, showing a universe governed by laws we can learn. Its 33 billion ton mass, potentially from a dense, thick disk star, and its 7 billion year journey remind us of our shared origins with the stars. As one ex user wrote, "It's just dust and ice, but it makes me feel connected to everything." This connection, reinforced by science, replaces dread with wonder, affirming that even in a 93 billion light year universe, we can find meaning. The comet's signals also echo Earth's own. Our radio waves, radiating 100 light years since the 20th century, carry our voice to the stars. 3I Atlas, carrying no signals, but the chemistry of creation, suggests other worlds might send similar envoys. While SETI remains silent, the comet's organics fuel hope that life's potential is widespread, a cosmic commonality. As it fades visible again in December, its data will endure in archives, inspiring future generations to look up, to dream, to discover. As we approach the comet's farewell, its legacy shines. The hope in its data, scientific, cultural, technological, lights a path forward, uniting us in a shared quest. It's a reminder that curiosity grounded in evidence can overcome fear and division. As we prepare to bid 3 Atlas goodbye, we carry this hope into the final chapter, where its departure leaves us not with loss, but with a deeper understanding of our cosmic home. As 3I Atlas approaches its final visible moments in our skies, nearing its October 3rd, 2025 flyby of Mars's orbit, before fading into the cosmic void by December, its faint glow carries the weight of a profound journey. This interstellar comet, a 33 billion ton relic with a 1.4 to 5.6 kilometer nucleus, has captivated us since its July 1st discovery by the Atlas telescope in Chile's Rio Hurtado. Its A21 CO2 to water ice ratio, organic rich dust, and hyperbolic path at 58 kilometers per second mark it as a natural wanderer, likely 7 billion years old, born in a red dwarf's protoplanetary disk in the Milky Way's thick disk. From JWST's August 6th spectra to Hubble's July 21st, images from amateur snapshots on X to ESA's impending Mars orbiter observations, it has woven a story of scientific rigor and human unity. Our speculative dreams of parallel universes, while poetic, found no footing in evidence, no isotopic anomalies, no unexplainable trajectories, just a comet behaving as comets do. In this final chapter, we bid farewell to 3I Atlas, reflecting on its scientific legacy, its philosophical resonance, and the hope it leaves behind, a testament to a universe that is both mysterious and knowable, where humanity's curiosity lights the way. The scientific legacy of 3I Atlas is a beacon for future exploration. Its data, meticulously gathered by global observatories, offers a window into planetary formation across the galaxy. The comet's chemistry, 80% CO2, 20% water, with silicates and organics, in its reddish dust mirrors, the building blocks of worlds, as seen in our own comets, like 67P, and in ALMA's observations of disks around stars, like Proxima Centauri. Dr. Bryce Bolin, in a Caltech seminar, called it a snapshot of another star's nursery. Its cyanide and nickel emissions, captured by the Very Large Telescope on August 27th, aligning with universal processes. As ESA's Trace Gas Orbiter prepares for its October 3rd flyby, probing for trace gases like ammonia, and NASA's JUICE mission aligns for a possible November glimpse. The data will enrich our understanding of how planets coalesce from dust and gas. This legacy, archived in open access databases, will fuel studies for decades, informing models of exoplanetary systems and inspiring missions to intercept future interstellar visitors. Beyond its chemistry, 3I Atlas teaches us about galactic dynamics. Its hyperbolic orbit, mapped by the Minor Planet Center and refined by pre-discovery images from June 14th, shows a path from Sagittarius near the galactic center, suggesting ejection by a gravitational kick billions of years ago. Dr. Maria Falsner's models estimate that such objects pass through our solar system yearly, yet detecting them is rare. 3I Atlas is only the third confirmed interstellar visitor after Oumuamua and Borisov. Its 33 billion ton mass, potentially from a dense, thick disk star, and early activity at 6.4 AU, seen by TESS on May 7th, refine our understanding of cometary resilience and interstellar migration. Future telescopes, like the Vera C. Rubin Observatory, will build on this hunting for more such wanderers to map the galaxy's churning currents. The comet's philosophical resonance is equally profound. Its 7 billion year journey surviving cosmic rays and micrometeoroids mirrors our own fleeting existence on a 4.6 billion year old planet. As it fades from view visible briefly in December before exiting forever, it evokes transience, a reminder to cherish the moment. Yet its predictability, governed by Newtonian gravity and measurable chemistry, counters cosmic dread. The universe, vast as it is, with 100 billion galaxies across 93 billion light years, follows rules we can learn. Dr. Jacqueline McCleary, in a NASA podcast, said 3I Atlas shows us that the cosmos isn't chaos. It's a story we're reading. Our speculative musings, imagining it as a multiverse envoy, found no evidence as NASA's July 20th statement debunked artificial origin claims. Instead, its natural beauty soothes, affirming a universe where wonder and order coexist. This farewell also celebrates humanity's unity. The comet's study, from Atlas's discovery to amateur images like Chris Schuer's July 4th, shot united scientists, students, and stargazers. On X, 3I Atlas trended with posts from Chilean star parties to Hawaiian classrooms where Shadow the Scientists' August 27th streams inspired young minds. This global gaze, in a world often fractured by division, shows our capacity to come together. The comet, indifferent to earthly strife, became a shared focus, its green glow a symbol of collective curiosity. Educational outreach, like the University of Hawaii's webinars, ensured its lessons reached all, fostering hope that knowledge can bridge gaps. The hope 3I Atlas leaves behind is its greatest gift. Its organics potential, seeds of life, suggest that the galaxy is rich with possibility, even if SETI's silence persists. Our own radio signals, radiating 100 light years, mirror the comet's journey, carrying our voice to the stars. While it carries no life, its chemistry hints at worlds where life might bloom, fueling dreams of future discoveries. Technologically, it pushes us forward. Proposals for interstellar probes, sparked by its visit, envision a day when we'll catch such wanderers. Philosophically, it grounds us in a knowable cosmos where science turns mystery into understanding, replacing fear with awe. As we bid farewell, imagine lying under the stars, the comet's faint light a final whisper. It's not a portal to other realities, but a messenger from our own, teaching us that the universe, though vast, is ours to explore. Its legacy, scientific, cultural, philosophical, lives on a spark for generations to keep looking up. The universe is strange, yes, but wonderfully knowable. And humanity, united in curiosity, has the tools to understand it. With 3I Atlas's departure, we don't mourn, but celebrate carrying its light into the future, where new wanderers await to tell their stories.